All right, let's jump right in. We're going to talk about something you see every single day, that 5-digit code on your mail. But what if I told you that simple zip code could be secretly wrecking your data analysis? Hey everyone, and welcome to Call the API. This is the show where we get our hands dirty with real-world APIs to pull down some amazing data. And today, man, we are unlocking a goldmine of free geographic info from a source you definitely know. But first, let me ask you something. Are you analyzing data by zip code, making maps with it? If you are, you could be making a really dangerous mistake. Seriously. But don't worry, we're not just going to point out the problem. We're going to show you exactly how to fix it, and it won't cost you a dime. Okay, so first things first. We need to shatter a really common myth. I like to call it the zip code illusion. And it's all about how the maps you're making, well, they might be lying to you. So, let's get down to it. What even is a zip code? The name itself, Zone Improvement Plan, sounds super geographic, right? But it's kind of a lie. Zip codes were made up by the Postal Service for one thing and one thing only, making mail delivery easier. They were never, ever meant to be stable geographic areas for doing any kind of serious analysis. And just look at this map. It shows you the absolute chaos I'm talking about. Zip codes aren't neat little polygons. They're just collections of delivery routes. They overlap, they have these weird little islands inside other zips, and they couldn't care less about actual boundaries like city or county lines. You try to pour your precious data into these messy, sloppy buckets, it's a recipe for disaster. Now, the US Census Bureau, they're smart folks. They saw this problem, and they tried to come up with a fix. They called it the ZCTA, or Zip Code Tabulation Area. It's basically their best shot at creating a clean, mappable shape that sort of looks like a zip code. But the key word here, and you really got to remember this, is approximates. And this diagram shows you exactly how they do it. The census takes a really tiny area, a census block, and looks at all the addresses inside. They see which zip code pops up the most, and then, boom, they assign that single zip code to the entire block. It's really just a statistical best guess. It's an imperfect layer they put on top to hide the mess underneath. I mean, it's better than nothing, but it's not the real deal, not the ground truth. Okay, so you might be thinking, this is just some technical detail for data nerds. But no, this is a huge deal. This imprecision has serious, real-world consequences. It can literally hide the truth in ways that affect people's lives. And hey, don't just take my word for it. Real experts like Dr. Nancy Krieger over at Harvard have been shouting about this for years. She calls using zip codes for this kind of work flat out unacceptable. That's a pretty strong word. Let's make this real. Think about the Flint water crisis. When the state first analyzed the blood lead levels, guess what they used? Zip codes. Here's the huge problem with that. Flint's zip codes don't just cover Flint. They stretch way out into the suburbs, into towns that weren't even on Flint's contaminated water system. So what happened? They lumped in thousands of perfectly healthy people with the people who were being poisoned. The result? It watered down the data, it diluted the results, and it tragically hid just how severe the crisis really was for the people of Flint. $241,344. What is that? That's the difference in the median household income between the richest and poorest neighborhoods that are all stuffed inside one single zip code in Miami. One zip code holds both extreme wealth and deep poverty. If you just take the average for that zip, you completely erase both of those realities. They just disappear. Okay, enough doom and gloom about the problem. Let's talk about the solution, because there is a fantastic one. It's precise, it's stable, and best of all, it's totally free from the US Census Bureau. It is time to unlock what we call Census Geographies. The census gives us this beautiful, logical system. It's a hierarchy. Think of it like Russian nesting dolls. You've got the whole nation, then states, then counties, and then you get down to the really good stuff, the levels that are perfect for analysis, census tracts, and even smaller, block groups. So let's put them side by side. Zip codes, they're for mail. Their boundaries are a mess and can change anytime. The number of people in them is all over the place. Census tracts, they were built from the ground up for statistics. Their boundaries are stable. They only change once a decade. And they're designed to have roughly the same number of people, which makes them perfect for doing real apples-to-apples comparisons. And here is the absolute best part. You can get all of this amazing, high-resolution data for free. Using the Census Geocoding API, you give it one single address, and it gives you back a treasure trove of information. I'm talking precise coordinates, the county name, the census tract code, the even smaller census block code, and get this, it even tells you the specific elementary, secondary, and unified school districts for that exact address, all from one API call. All right, time to roll up our sleeves and get our hands dirty. Let's walk through exactly how you can pull this down in with a super simple Python script. Consider this your mission briefing. It's really just a 5-step process, super straightforward. First, you build the URL for the API call. Then you import the libraries you need. Step 3, you actually make the call and, importantly, handle any errors. Fourth, you parse the JSON that comes back. And finally, you extract the exact geographic data you're looking for. Simple as that. You literally only need 2 Python libraries, and they probably came with your installation. You'll need requests. That's the magic that lets your code actually talk to the internet and hit the API endpoint. And then you need JSON. Think of it like a universal translator. It takes the text response the server sends back and turns it into a Python dictionary that's super easy to work with. Okay, now here's a huge pro tip. Please do this. Right after you make your API call with requests, the very next line should be response.raise_ for status. This is your safety net. It automatically checks if something went wrong, like the server is down or you made a typo in the URL. If it finds an error, it'll stop your script right there instead of letting it crash later on with confusing errors. It is absolutely crucial for writing solid code. So when that data comes back, it's going to be in a format called JSON, which looks a bit like a set of nested Russian dolls. Once you load it into a Python dictionary, you just have to, navigate through the layers to get to the good stuff. You'll go through keys like results, then address matches, then geographies. Inside geographies, you'll find everything, census tracts, unified school districts, you name it. You just have to point your code to the right spot, like geographies, and then unified school districts to grab the school district name. It's really that direct. And just like that, with a few lines of code, you've completely upgraded your toolkit. You now have a way more powerful, way more precise lens for looking at the world. You can finally go beyond those random, arbitrary boundaries that were just designed for the mailman. So let's just recap the big takeaways, right? Number 1, zip codes are for mail, not for maps. Please burn that into your brain. Number 2, for real statistical precision, you want to be using census tracts and blocks. Number 3, the Census API is your free and powerful ticket to get all this data. And finally, remember that one single call gets you a ton of stuff, like school districts, county info, and so much more. You know, when you move past zip codes, you're doing more than just changing a tool. You're fundamentally changing the resolution of your camera. You stop seeing the world in these blurry, averaged-out pixels, and you start seeing the crisp, high-definition patterns of how people actually live. So now you've got the toolkit. You can do analysis that's more accurate, more ethical, and frankly, just way more insightful. So the only real question left to ask is, what hidden patterns are you going to uncover?